Alright, what we see here is the Jinxt3r prototype out on the bench here, and there's a number of components that make it. So as I prototype, I add and subtract them to try and figure out the things that I like. So the most important thing is the main board here. This is a Cortex-M4 board that I'm using, and ultimately the Cortex-M4 processor will be on the system. And then over here we've just got some solderless breadboard with some various sensors on it, some accelerometers, gyro, magnetometer, altimeter, and then over here we've got another board with magnetometer, gyro, altimeter as well. Alright, and so now we'll kind of come back here so you can see kind of the view. So all this will end up in a tiny little wearable computer. And now we're going to come in and we're going to focus on the screen here, which the demo that we're going to do is going to be all about. Okay, alright, so what we're looking at here is a development ID and a little COM serial port window, terminal window. So the first thing is take a look here at the entire kind of Jinxt3r development platform. So here's kind of what everything looks like. Alright, and then now what we have here is the screen. We've kind of squared this up so you can kind of see the LCD screen. Because that's what this video is about, show you a little bit of the graphics. They're very simple right now. You know, obviously you can run games and whatever else you want here, but this is just experimental as I'm developing the software. All right, so coming back to the screen now. So this main application that we have right here is a development platform, and what this is for is to write the software. So this is a Rowley Crossworks, and this is a pretty good development tool for ARM and the ARM platform, Cortex specifically. So what we have here is a few thousand lines of code, which are the application that I'm currently running, which is kind of a rudimentary operating system kernel, API, platform framework, and a ton of drivers for experimenting with all the different sensors and LCDs and cameras and all that I'm working on as I put together this design. So that's what this whole thing is. All right, then what we do is we talk to the system with a console terminal. So I've written a console terminal, something like a DOS or a simplified bash that you can communicate to the system with in real time, which really makes it really easy to operate and use. So we can see here, a little window here, and as I type, you know, whatever I type here happens over here. So the first thing is, let's kind of get the system in a neutral. So we're going to go back to the tool here, and I'm going to download to it so you can see it's doing what it's doing here. Then over here, now it's done that fast, that compiled and downloaded that quick. So we go back to the window, all right, and again, taking a look at the screen over on the actual Jinxt3r itself. See, it's black here, all right. And now we'll come back to the command window here. So this is a little terminal, so I can type in it, you know, type whatever I want. And it's got a few commands in here. And there's a little driver for every single device. Now, one of those drivers, of course, is the LCD. So let's go ahead and let's play with the LCD. So the first thing we need to do is initialize the LCD. So I'm going to throw this command at it, LCD init, which is going to take care of the bus interfaces on the hardware on the Cortex chip. Then after we got that, then we've got a layer of software that's going to start sending commands to the LCD to tell it to initialize. So we're going to go ahead and put the camera on the LCD now and run this command and see what happens. All right, so you saw that flash there of text, and that was what was in the frame buffer beforehand, and now the frame buffer has been filled with this blue. All right, so now we're going to come back to the command shell here. And you can see we can type here. So now what we're going to do is now we're going to basically say we want to run the graphics driver. So now there's the LCD driver, then on top of that we have the graphics driver. So now we're going to turn the graphics driver on, which has to do with polygon graphics, bitmap graphics, clipping, color conversions, scaling, all that kind of stuff. So now what I'm going to do is throw this command at it. And so again, let's take our look at the actual LCD and watch what happens. All right, so now it just ran a little post test and kind of, you know, said RAM and memory and all these little things. This is just really printing stuff out for fun. And then we've got the command prompt. Now what's happened is because we've got another little screen, I've written software that will also stream the I/O to the little screen. So when I type on the keyboard, on the computer, it'll actually go through the terminal and then also show up on the screen. So you can see as I'm hitting return here, and we can say clear the screen, and then the screen clears, and we got a little cursor. Now we'll come back to the screen over here on the computer, and as you can see, I hit CLS, and so we got kind of two screens. So you can kind of see what we're doing here on the computer, and then of course it's mimicked over on the screen on the Jinxt3r prototype. All right, so let's go ahead and we're going to go back to the Jinxt3r now, and we're going to kind of do everything from there. So we're going to type in LCD, and then the command we're going to do is asteroids, if I can spell it right. There we go. And what this is going to do, it's going to execute another application and call that application. And the application is going to completely run by itself as if it were a separate binary. In other words, there's not a lot of intercommunication between this kind of global shell and the sub-application. That's kind of the architecture that the final system will have. So we'll go ahead and we'll run this little asteroids here. All right, and once that runs, as you can see, it's a little tiny asteroids game. This is ported from one of my books, ported it, in about a couple hours because it was in C++. So I had to kind of get C and C++ to work together nicely on the platform IDE. But it's all working. And you can see the text there. You can actually read it. And this display is 128 by 128. This particular game has a scalable vector engine that I developed, so any resolution, any size, it'll scale to it automatically, and then you can scale the text up and down a little bit so you can make sure to read it. So surprisingly, with even a little 128 by 128 in this vector font, it's legible. So we're going to go ahead and start the game. And this is, exactly what it looks like. It's just a little fun little version of asteroids that I wrote in a day or two. Not recently, many years ago. Anyway, and you can come here and shoot stuff and all that. So this is a great test of the little vector graphics system. And what I really wanted to do in this test is I wanted to verify that vector games would look good on a tiny screen. And as you can see, they look great. And this is an LCD, not an OLED. Now an OLED is going to be even better. So I was pretty happy with that. As you can see, collision detection doesn't work. And the reason for that is so I can do this demo and not die constantly. All right, so if we press escape once, it goes back into kind of demo mode here and it holds off. If we press it again, the application will exit and then return back to the kind of little operating system, kernel, shell, whatever you want to call it, and boom, there it is. All right, so now let's go ahead and let's run another command. So let's run Raiders 3D, and this is another game I wrote for one of my books in the introduction, which is just a little simple 3D game, and kind of reminiscent of Star Raiders if you're an Atari fan. And you kind of have this little cursor here, crosshair, and you shoot these little guys. If I can hit one, let's see if I can get one. There we go. And it's a little polygon 3D game with 2D kind of wireframe objects for the 3D to represent the 3D. But the game is actually completely 3D. This is fully 3D rendered and projected. It's just wireframe. So again, just testing the pixel plotting and the line drawing to see if you can see objects on one of these tiny screens, because I'm trying to ascertain what the size is of the screen I can use. All right, so nothing really impressive. I could port Doom to this if I liked, but that would be a waste of time right now because we don't have the hardware done. So these are just tests right now. So again, we'll press escape and immediately we come back. And just to show you that we didn't frag anything, we can go back here and we can execute the program once again. And it'll just launch, and there we go, completely reset. All right, so now let's go ahead and let's do something to show you a little bit of color. And we're going to run a little demo that just puts a little slideshow. So here you can kind of see, it runs pretty fast, but you can see the quality and the resolution of this little display. And again, 128 by 128. This is 262,000 colors, 18-bit actually. It's not OLED, but it is quite impressive, as you can see. And the slight color distortion you see is we've got two things going on. We've got an iPhone that's doing the video right now, so I didn't do any color compensation or adjustment. And when the images were brought in, of course, these are photographs brought into the computer and then converted and then put back into C code. And of course, there's no color transforms. I could adjust all this all day long, the hue and whatnot, anywhere I wanted, but I just wanted to get the images into the computer. Now, let's go ahead and hit escape. Now, here's something interesting. So you can see we're right back in the terminal here, and I can do this, and you can see it can scroll. So you can see graphics and text mixing together there. So that is the system and that's what the graphics are capable of. So now we're just going to continue evaluating LCDs and OLEDs. Now I think we're to the point where we know we're going to use an OLED display and get some drivers for that. And then the next question will be the size. This is a 1.45 or 1.5 inch diagonal screen, square, 1:1 pixel ratio size. And we're going to move this probably to a 1.7 or 1.8 inch screen diagonal, which will give us more of a rectangular view surface, which will be better for 16:9 viewing or to watch movies and things like that. So I think it'll be worth it to make the screen a little bit taller. So that'll be kind of what we do next. So anyway, that is the end of the video, and I'll be back soon with some other cool stuff.